Hi, welcome to our geometry lesson today. You can see we're looking at section 1.7 from your textbook, and today we're going to be talking about finding the midpoint between 2 points and the length of a segment, or the distance between 2 points in the coordinate plane. We are going to begin though on a number line. So as you take a look at the number line here, a midpoint, as we have previously said, splits a segment up into two equal pieces. And you can see that the point M is the midpoint of segment AB. The formula for finding the midpoint on a number line goes as such. It's add the two coordinates together, so A plus B, and you want to be exactly in between them, divide by 2. As you look at this example, I hope that we'll see very quickly that that works out exactly correctly on this number line. The coordinate of B is 5. The coordinate of A is -3. You can see that in between. Formula says divide by 2. 5 plus -3 is 2, and 2 divided by 2 is 1, and that's exactly where this midpoint is. On a number line, add the coordinates, divide by 2. When you move into two-dimensional space, things change a little bit. Not only do you have to worry about being in the middle horizontally, you also have to worry about being in the middle vertically. So what we're going to find is the midpoint in the coordinate plane is a point with its own x and y coordinates, and you find the x coordinate by adding, I'm going to write over here, this has its own x1, y1. This has its own x coordinate and y coordinate. And the formula says, do the same thing that you did here. In the horizontal distance, or direction, in the horizontal direction, add the two x's, x1 plus x2, and divide by 2. That'll get you the middle going across. That's the x coordinate of the midpoint. To get the y coordinate, you add the two y's together and divide by 2. Again, that averages or gives you the middle of the vertical distance. As far as this thing goes, the point A is at -3, -4. The point B is located at 5 and -2. Formula says to find the midpoint, M, we are going to add together the two x's and divide by 2. 5 plus -3 over 2. I'll do the arithmetic in a minute. Add together the two y's and divide by 2. -4 plus -2 over 2. Do the simplifying. 5 plus -3 is 2. 2 over 2 is 1. -4 plus -2 is -6. -6 divided by 2, -3. And if our formula worked right, we should see that point M is located exactly there. Over 1, down 3. Yay, it works. Okay. Let's go on and talk a little bit about now some examples. We'll give you a chance to practice this. I am going to ask you to pause the video, and I'd like you to do these two examples, please. We will check back in just a moment. Okay, let's get together and check here. I've come up with, for a midpoint on the number line, adding together the two coordinates, dividing by 2, 2.5. That would put the midpoint right about there, and that looks to be precisely the right location. Down here, I've added together my x's, divided by 2, added together my y's, divided by 2, and according to the formula, the midpoint on this segment should be at -1.5, so back -1.5, and then down 0.5, and that puts the midpoint right there, which again looks exactly correct. Okay, that formula is nice for finding a midpoint. We'd like to give you an example of a little bit of an extension of this idea. This time we know the midpoint. Okay, the midpoint is right here at 0. Actually, I'll put the coordinates there. 0 and -2. Point A is over here at -3, -3. And what we're supposed to do in this example is find the coordinate of point B so that it puts M right in the middle. Now, ladies and gentlemen, we could work with the formula to do this. However, that's probably not the easiest way to solve this problem. It is true that the midpoint has to be exactly in between. So if you look at what it takes to get from A to M, that is, you must go up 1 while you go over 3. If we duplicate that same thing here, up 1 over 3, we will have the coordinate of that point B. Again, what we did, I'm going to change color here. We looked at what it takes to get from A to M, and we said, okay, that's halfway. Let's do it again. There's the end point. This is a logical way of finding that midpoint, shown to me by a student many years ago. I've never forgotten it, and it's much easier to do this than to substitute into the formula. All right, we're going to go on and talk a little bit about distance now. Finding the distance on a number line is something that you've done before, and we're not going to review that, but we are going to talk about finding the distance in the coordinate plane. And I am going to say again that point A has its x value and its y value, x1, y1. Point B has its own x value and its y value, x2, y2. And I want to give you the formula, and then we're going to look at another way that you could come up with this distance. The formula is big and looks nasty. It's really not so bad. What it says is you take the square root of, and you need to find the distance between the two x's. So as you think about that, the horizontal distance that you have to move, well, it's this x minus this x. That's how far it is across. That would be x2 minus x1. And the formula has a squared there, x2 minus x1 quantity squared. Then you do the same thing with the y's. You say, okay, to get from this y to this one, I would subtract y2 minus y1 and square, and then the formula says take the square root of all of that. Now, ladies and gentlemen, I would submit to you the distance formula is based on the Pythagorean theorem, which you already have some familiarity with. In fact, if you think about it, the Pythagorean theorem says that in a right triangle, if you square the two legs and add them together, that's the same thing as the square of the hypotenuse. Now, if you carry this algebra out a little bit, taking the square root on both sides to get the c by itself would say that c, which is really the distance between points A and B, that c is equal to the square root of a squared plus b squared. You guys, what we did up here is find what a is. A is this distance, y2 minus y1. That's a. This distance, x2 minus x1, that's b. And what we said up here is to find the distance, right? We take the square root of the a thing squared plus the b thing squared. That is applying the Pythagorean theorem. The distance formula gives us a handy way to do distances if we don't have a picture. If I have a diagram, I'm almost always going to go with the Pythagorean theorem because it's what we know best. Let's see if we can apply that. Here it says that we should find the distance between point A and point B. It says we should round to the nearest tenth if we have to. Ladies and gentlemen, there is no diagram here, so this is a time for the formula. To find that distance, we are going to take the square root of the difference between the two x's squared plus the difference between the two y's squared. Okay? And I'm going to go ahead and put x1, y1. I'm going to suggest that you do this for the first several times because it'll help you get straight in your mind which part goes with which part. So, plugging into the formula, x2 is 4, x1 is negative 7, 4 minus a negative 7. Formula calls for squaring. You add to that, and I'll do the arithmetic in a minute. Now it's y2 minus y1. That's negative 3 minus 5. Quantity squared. We got to do a little work here. 4 minus negative 7 is 11. Minus a minus is like adding. And you have to do the subtracting in here before you do the squaring. Negative 3 minus 5 is negative 8. And that'll be squared. Now I'm going to ask you to use your memory. 11 squared. Do you know this one? It's 121. 11 times 11 is 121. Negative 8 squared, negative 8 times negative 8 is 64. And together, 121 and 64 is 185. The square root of 85 is that value. We're asked to round to the nearest tenth if we have to. My calculator. The square root of 185. Around 13.6. All right, to the nearest tenth. Here, our last example, we do have a diagram. April and David, it says, live in Rect City, which is kind of neat. They're in a rectangular coordinate system. Each grid line represents 3 miles. We're to find the distance between their houses. What I said is if I'm looking at a diagram and I want this distance, whoops, one line would have been good, then I'm going to probably think Pythagoras if I have a picture. And we have one square there, but remember that that square is worth 3 miles. So really that comes out to be a length of 3. We have 1, 2, 3, 4 squares there. And each square is 3 miles. So this side is 12. To find the distance between their house, Pythagoras says, and I'm going to call this D, that D squared is equal to 3 squared plus 12 squared. We have to do a little arithmetic. 3 squared is 9, 12 squared is 144. D squared then is, let's add those, 153. And the distance between their houses would be the square root of 153, which to the nearest tenth, calculator again, square root of 153, about 12.4. All right, that's the end of our lesson for today. I will remind you, I need you to get out there and do the U-Try as quickly as you can. Those are due before class the next day. That's how I learn what we need to talk about in class. You will definitely want to have a calculator tomorrow. If you have not gotten one from the library, it would be a good idea to do it before class tomorrow. Okay, have a good night.